Okay, I want to welcome you to our very first flipped video of the year, and we are going to start with reading and writing large numbers. So the first thing I'd like you to do is make sure you have your Cornell note page, and when I'm finished reading these, you're going to pause the video, and I'm going to have you make sure you write down the learning goals. So the two learning goals for today are I will be able to read and write whole numbers to the billions, and I will be able to understand and translate standard notation, expanded notation, and number and word notation. So I'd like you to take a second to pause and write those two learning goals down. Okay, now that you have those down, I want you to kind of think back to our pretest and now think about how you did on those two learning goals. And also take a second to write down standard notation, expanded notation, and number and word notation. That is what we will be working on today. All right, we're going to start with standard notation. And standard notation is probably the most familiar way of representing whole numbers. You've been writing in standard notation probably since you've been taught to write numbers. In standard notation, the digits are written in the specified places determined by the place value chart. For example, in 3,298, we have the 8 in this particular location because it's 8 ones. The 9 is there because it's 9 tens. The 2 is 200s, and the 3 is 3,000s. So when you're writing in standard notation, you are writing based off the place value chart. So here's an example of our place value chart. And we're going to talk a little bit about place value chart. Right here, I'm just showing the ones period. Each of the different sections of the place value chart are called periods. And we have our ones column, our tens column, and our hundreds column. And you'll notice as we move left in the columns, each value, the 1, is multiplied 10 times because the tens column is 10 times greater than the ones. The hundreds is 10 times greater than the tens. If we keep moving on, the next one we have is the thousands period. And we have our 1,000s, 10,000s, and 100,000s. And the way we separate between the ones period and the thousands period is by using a comma. After that, we have our millions period, and we have the same thing. We have our comma down here separating the thousands period from the millions period. And we have our same ones, tens, and hundreds, this time in the millions. And each time we are going 10 times bigger than the column to the right. After that, we have our billions period and our trillions period. And so the same thing, we have our commas separating the different periods. And when we read the numbers, we read them based on their period. So this is written as 17 million because that comma separates the millions from the thousands. And each of these numbers represents how many of that value we have. The next one we're going to talk about is expanded notation. And just like it sounds, it's when we are going to expand out the number. And so when you're writing an expanded notation, you are taking the number and you are expanding it out as a sum of the value of the digits. And whenever you have a sum, you are talking about addition. And so, for example, if we look at the place value chart for this number, 281, we have 1 1, we have 8 tens, and 2 hundreds. And so when you're writing in expanded notation, we start with the farthest left number, which is our 2, and it is 2 times 100 is the value of that number. And I'm going to put parentheses around it, and I'm going to add it to the next number. The next number we have 8 times 10, since it is in the tens column right there. We'll put our parentheses, and we're going to add that to 1 times 1. Now, one thing I want to just point out quick is that I am using a dot for my multiplication instead of my x. They mean the same thing. I choose to use the dot because when we get into algebra, it's just easier to be able to tell if I'm multiplying or using a variable. So this is an example of expanded notation. So if you look on this page, we have 3 other numbers, and we have our place value charts to give you a hint. What I want you to do is I want you to pause the video, and I want you to write out each of these in expanded notation. Okay, so if you go ahead and look to see if what you did matches what I did, in this one we have 2 times 1,000 to represent the 2 in the thousands place, 3 times 100, 4 times 10, and 7 times 1, and is expanded out. In this one we have our 3 times 10,000, 6 times 1,000, 1 times 100, and you'll notice right here, because there is a 0 here, I did not put in a notation for that 0 times 10, since we know 0 times 10 is 0. So we can leave that out. And in the bottom one, we have 4 times 10 million, plus 8 times 1 million, 2 times 100,000, and so on. This one is obviously quite long due to all the numbers. And later in our unit, we will talk about how we would be able to write that a little bit differently. The next one we're going to talk about is number and word notation. And number and word notation is written using a combination of numbers and words. It consists of significant digits of a large number followed by a word for the place. Okay, so let's take this number. This number is 27 million. What we're going to be looking for is we are going to be looking for the significant digits of a large number. And what you're going to look for is what are the largest digits you have and what is the first period that you have that separates them from the rest. And in this case, we have our 27 in our millions period, and we have zeros in the rest. So what we do is we take our significant digits, which are 27, they go where the number goes, and we write the word million. So just like the title says, number and word notation is a combination of numbers and words. Okay, so let's take a look at this one. In this one, we're going to look at our significant digits, and our significant digits are represented here and here. And in this case, we have significant digits in 2 different periods. When we write this in number word notation, we are going to convert our comma to a decimal, and we would write this as 46.75 million, and that would be our number and word notation for this one. You can also look at number and word notation and convert from number and word notation back to standard notation. With that, what you would do is you want to pay attention to the place value that they have here, and they have it at billions. You should also notice right here that we have a decimal, and that decimal place is going to tell us where our comma is going to go, with billions being on the left-hand side. So we know our comma will go there. So we would have 203.6, and we fill the rest into zeros. So when we're translating from number and word notation to standard notation, we want to look for those things. We want to look for our period notation, any decimals, and these are then our significant digits. Okay, I'm going to have you go ahead and give it a try. So here is our number in standard notation. I would like you to pause this briefly and write this number down in number and word notation. Okay, so if you were writing this in number and word notations, you're looking at the significant digits. We have our comma, so we would have 900,000. Now, one thing you might have noticed is that the number and word notation is no different than when we read it. There is one other way you could write this. Because 9 is the farthest number to the left, it's right next to the millions period. You could also have written this as 0.9 million, or 9/10 of a million. So there's 2 ways you could have written that. All right, let's do one more. I'm going to give you the number and word notation this time, and I'd like you to write the standard notation. Same thing, pause this quick, and if you would write the standard notation. All right, so what you should have done is looked for this word, the billions, which is right here. Notice the decimal, put your comma, and you would have an 85000. 0, 0, 0, comma, 0, 0, 0. So that would have been the standard notation for that one. All right, and the last thing I want to cover today is converting our notations. Converting our notations is basically taking one type of writing of a number and converting it or changing it into another. So in this case, we are going to take expanded notation and convert it to standard notation. What we're going to do when we do that is we're going to solve this equation just like we would any other equations with parentheses. We'd start with the numbers that are within the parentheses. So we're going to start with 7 times 10,000, which we know would be 70,000. 5 times 1,000, which we know would be 5,000. 7 times 10, which would be 70, and 9 times 1. And then what you basically do is you add them up. And so we would have 7,500. We'd want to pay special attention that there was nothing times 100 here, and we need to have the zero placeover holder and 79. Standard to number in word, we would look for our significant digits, and in this case, the 802 and the 5. We see the decimal between those two, or the comma, so we know we need to do a decimal. So we would have 802.5, and then we want to count to the place values. Here we have the thousands, millions, billions, so 802 billion. And then the standard to expanded, we start with each one, multiply it by its place value, our 8 in our thousands place. Going to add that to our 3 in our hundreds place. Add that to our 2 in our tens place. And add that to our 7 in our ones place. And so that is covering, if we go back to our learning goals at the beginning, understanding how to read and write whole numbers to the billions, and understand and translate standard expanded number and word notation. If you have any questions, please write them on your Cornell Notes page. You can go back and replay this if you want to add anything else, if you didn't get your definitions for the notations, or you want to practice some more translating. Go ahead and do that, and we'll see you tomorrow.